All right, everyone, let's take a look at our next section, Coterminal and Reference Angles. Now, before we get into anything new today, let's remember what we learned in our last video, which is converting from degrees to radians and back. So at this point, you should go ahead and pause this video, try the 3 warm-up problems, and unpause it when you are finished. Okay, so let's take a look at our answers for our warm-up problems and the work that goes along with it. Pretty important that we know how to convert back and forth for the rest of this chapter. So for now, let's take a look at what we're learning today. All right, the first thing we're talking about today is called coterminal angles. We already know that terminal means the second ray, the ending ray of the angle. Co, usually, as we know, the prefix usually means together or the same. So coterminal are 2 angles that have different measures, but they end up with the same terminal ray. So it says here if it's an alpha, it's a Greek letter that kind of looks like an A. If alpha is the degree measure of an angle, then all angles measuring A plus 360n, where n is some integer, are coterminal with alpha. So the question is actually 3 questions here in one. Identify all angles that are coterminal with a given angle, then find one positive and one negative angle coterminal with a given angle. Okay, to find all angles, it's actually really simple. We're just going to write the angle measure that we know plus 360n. That represents all angles that are coterminal. All right, now to find one positive angle, all we're going to do is put 1 or 2 or 3 or 4 or any number, any positive number in for n. So let's just do 345 plus 360 times 1, which is just 45 plus 360. And that answer would be 405 degrees. To do a negative, we're going to do 45 plus 360 times some negative number, so -1, -2, -3, whatever. Make sure our final answer is negative here. So it'll be 45 minus 360. Let's see what that would be. Negative 315. All right, so what this problem just showed is that 45, 405, and negative 315, while all are different angle measurements, they all would look exactly the same on a coordinate plane. They all would have the same initial ray and the same terminal ray. Now, one might go counterclockwise versus clockwise, or one might go around in a circle more than once, but they all have the same 2 rays on the coordinate plane. Question B, negative 130. So that would be negative 130 plus 360n. That would be all angles. All right, now a little bit of a shortcut here. Really, all we're doing is we're going to add 360 to this. And that would give us 230. And that's our positive answer. And subtract 360 from this. And that's negative 490, sorry. And that would give us our negative answer. So again, these 3 angles, 1, 2, 3, have the same initial and terminal rays on a coordinate plane. Are there more answers than these 3? Absolutely. There are infinitely many correct answers. These are just 3 basic ones that we picked out. All right, last one, 375. So 375 plus 360n represents all angles. Okay, if we add 360 to that, so that would be 735. That would be our positive angle. However, this time, if we subtract 360 from this, we get a positive answer again of 15. That does not satisfy the request that we were asked in this problem. It says 1 positive and 1 negative. Right now, we have 2 positives. So what we got to do is we got to subtract another 360, subtract another revolution. And that would give us our answer. So here are our 2 answers, or you could do these 2 as your 2 answers. It doesn't matter as long as you pick 1 positive and 1 negative that are coterminal with that. All right, at this point, again, I would suggest pausing this video and trying these three on your own. Come back and check when you're ready. And here are your answers. Now, possible answers. There are infinitely many correct answers, but here are some possible answers for these three problems. The last thing we're talking about today is a reference angle. What is a reference angle? It's an acute angle formed by the terminal side of an angle and the x-axis. Now, you notice x-axis here is underlined. It's extremely important. This question is basically asking how far away from the x-axis are you? Let's remember what an acute angle is. An acute angle is some angle between 0 and 90. So our answer for reference angle always has to be between 0 and 90. Positive. 0 and positive 90. Okay? So how are we going to find reference angles? All right, so first I just drew an angle in each quadrant. So you can see an angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember, we are trying to get the positive angle closest to the x-axis. So if we're in the first quadrant, we're talking about this angle right here. That's just going to be theta. Whatever theta is, that's it. That's our answer. If we're in quadrant 2, to get this angle, since this is 180 and this is theta, we're going to do 180 minus theta, and that will give us our angle in there. For quadrant 3, we're talking about this angle down here. All right, and since this is theta and this is 180, we're going to do theta minus 180 to get that angle in there. And in the fourth quadrant, since this is 360 and this is theta, we're going to do, to get this angle here, 360 minus theta. All right, so some example problems here. Draw the angle and its reference angle and find the measure of the reference angle for each example. First one, 120. Let's start by drawing in a 120 degree angle. So here's our initial ray. Our terminal ray should be right about there. And there is 120 degrees. So the reference angle is, again, the closest, the x-axis closest to the terminal ray. So this is our reference angle right there. So we're going to do 180 minus 120, and our reference angle is 60 degrees. Question B, 30. So let's draw a 30-degree angle here. And our reference angle is actually the same angle because it's the closest to the x-axis. So we're in the first quadrant here. This is how it's always going to be. The first quadrant, the reference angle is your angle. Question C, 192. It's a little bit bigger than 180. So here's my initial ray. And my terminal ray will be right here. And this angle here is 192. So our reference angle is this angle right in here. So we're going to do 192 minus 180, and our reference angle is 12 degrees. Part D, 307. 307 is bigger than 270. So we're looking at somewhere around there. That angle would be 307. So our reference angle would be right in here. So to get this angle, we're going to do 360 minus 307, which is 53 degrees. 375. Now you might recognize this number is bigger than 360. So if we subtract 360 here, we get 15. So it's one full revolution and then also 15 more degrees. So our angle should look like this. And our reference angle closest to the x-axis would be right here. And that also happens to be 15 degrees. Last one here, 175. That's a little bit less than 180. So our angle is like right about there, 175. Our reference angle is right in here, which is going to be 180 minus 175, or 5 degrees. One last time here, I would suggest pausing this video and checking out the next slide for some practice. Come back and check your answers when complete. Here are your answers for the final 6 questions. That's it for our lesson on coterminal and reference angles. In the next video, we're going to start our look at the unit circle. Thanks again for tuning into the video today, everyone.